Yes, so the talk is called Ground Control to Nomad Job Dispatch. I've been in a really weird mood as far as my comedy goes, and I like setting up puns and then not delivering. And it's funny for me and no one else. As was mentioned, my name is Michael Lang. I'm Dean Deleting Fuzz on the internet, both on Twitter and on GitHub. And there's a story behind that, but I'm not going to go into it. It's not interesting. I'd rather talk about Nomad. And Nomad's a HashiCorp product. You've probably heard of it. If you've been on the stream all day today, you've definitely heard of it. And I am an engineer on this team. I've been working on this product for almost 3 years. It'll be 3 years at the end of May, working on the UI. If you haven't heard of Nomad, it is our workload orchestrator, and it's meant to manage any sort of containerized legacy or batch application. It's meant for highly available applications, multi-cloud, and super high performance scheduling. If you haven't heard of it, or if this is ringing bells, that's likely. There's another container orchestrator in the space called Kubernetes. If you haven't heard of that one, it's a similar product to Nomad, but I suspect you have. And a lot of the reason why people haven't heard of Nomad is because Kubernetes has had this sort of effect where it is blotting out the sun, but that's okay. We don't really mind hacking in the shade. But it does result in this question a lot. What is Nomad? I've been to a lot of conferences and I get this at reInvent and I get it at KubeCon, and that's understandable. But I also get this question at HashiConf, and that's kind of an interesting one. There are super fans and they're still like, wait a second, there's another product in your portfolio. And that's fine. I mean, there are hundreds and hundreds of products in this entire space, right? Amazon alone has over 100. So I don't expect everyone to know everything. But it got me thinking that we should probably create more beginner content just to get people in, because we like to talk about the bleeding edge stuff. If you were here, oh gosh, a good 12 hours ago, you heard another Nomad engineer talk about task drivers and device plugins. Great talk, but also bleeding edge. So this one's going to sort of rewind a bit. I just didn't know exactly how I wanted to do it. Fortunately, at the same time, I put together this questionnaire on monitoring and forecasting that the community was able to answer and sort of give us feedback about what they're doing with Nomad. And a couple of the questions in it, just to sort of get the lay of the land, was do you use periodic jobs and do you use parameterized jobs? 56% of people said that they use periodic jobs, but only 20% said that they use parameterized ones. And this kind of made me sad, like not in like a heartbroken kind of way, but to me, it was like, all of my friends at once told me they don't listen to my favorite band, except for one who wasn't sure. So I wanted to correct that. So I wanted to make sure this talk was focused on something that was beginner friendly, something that I think is high value, and clearly something that even super fans among Nomad aren't leveraging. So step in, what is a parameterized job? Except actually not. I did say this is gonna be beginner friendly. So let's first ask, what is a job? So this is sort of the standard job flow within Nomad. Starting in the top left in that orange box, you'll see there's a job file. This is an HCL or a JSON file. If you're used to Terraform, job files will feel very familiar to you. You submit that to Nomad servers. The Nomad server accepts that request and then figures out which Nomad client to place the job on. So here, you can sort of read it from left to right. On the far right, we have allocations for this job, which is the actual running work placed on clients. There's this dark gray client that doesn't have any allocations on it. So that's sort of meant to show that there's an entire constraint system within Nomad to help you place jobs where they can go. So within the authoring process of a job file, you can set up constraints, or you can say a certain task driver or whatnot, and then Nomad will make sure to avoid the clients that it can't be placed on. So for sake of example, maybe that Nomad client is a Windows box instead of a Linux one, and we can't run this Nomad or this Linux executable on a Windows box. So let's look at periodic jobs next, since that one's a little more popular. This one we like to call distributed cron. The idea is you author a job file the same way, but then you also say kind of a cron spec in it, just like if you're writing a cron task, and you give that to the Nomad server, and that doesn't actually run work. It just sort of holds onto this template, and then on a regular interval, just like cron, say nightly, say weekly, it spawns an allocation on a client and then goes down. So this is sort of a different construct from typical jobs. Typically, you run a job, it runs work. This is you run a job. It's a template. The template will eventually run work. Parameterized jobs are similar to periodic jobs. So a little more involved again, but here we start with a job file on number 1 here. That gets submitted to the servers. Servers hold on to that template, just like periodic. But this time, it takes user intervention to actually spawn a child instance. And that's through a command called job dispatch, which you can do via the CLI or the API. So once that job template is running, you can then dispatch instances of it. And I like to think of this as a function call. So the template is the function. And then when you're calling job dispatch, that's like the call site of that code. And of course, if this is going to be a function, then the function will likely take arguments. And you can provide those in the form of either meta params for things like small configuration or strings, or a payload, like a larger configuration. It can be JSON or binary, what have you. If that's feeling a little foreign as a web developer, I think it's helpful to reframe that in terms of HTTP. So you can think of meta params as like GET or query params, and the payload's like a request body or a post request. So that's the flow. I'll let that kind of sink in a little bit. And then we have our first demo. Now that we know what this parameterized job is, I wanted to create the simplest imaginable one. So let's first look at what that job file looks like before running it. So here we have HCL. This job is going to be called Hi. It runs in data center DC1. There's only one. And then from there, things get a little more interesting. So first, we want to declare this as a batch job. And it has a parameterized stanza in it, which is what says, I'm not a normal batch job that should just run. I am a parameterized job. Therefore, this is a template. And the payload is required. And then inside of this task group, we'll see that there is a dispatch payload stanza. And it's saying that payload that you give me, save it as a file called message.txt within the task that gets run. And then we're going to run this one command just using bash. And it's going to echo hello, and then a comma, and it's going to cat the file. And then it's actually going to sleep for 120 seconds. That's obviously not normal, but this is a demo, so just bear with me. You may have noticed there's a weird thing before message.txt. That's some interpolation of an environment variable, Nomad taskdir, and I assure you that'll make sense with time. So let's look at that demo. All right, I'm in a terminal. First, let's just kind of get a lay of the land. If I do Nomad status, that'll tell me what jobs are running, currently none. If I do Nomad node status, that'll tell me what nodes are in my cluster. It's just the one, which is this vagrant box that I'm in. So then let's go ahead and run. Actually, let's first cat hi Nomad, just so you know there's nothing going on my sleeves. It's here. I probably want this. So let's copy that too. And let's run it. So Nomad run hi. Registration successful. So now if I do Nomad status, I will see that I have one parameterized job. And then if I do Nomad status hi, you can see that this is parameterized. You can see it says payload required, like the job spec. And then the job summary, 0 pending, 0 running, 0 dead. And that's because we haven't dispatched anything yet. So let's take that command I put here, and let's just read through it real quick. So we're going to echo HashiTalks, and then we're going to pipe that to Nomad job dispatch hi. So basically what we're doing is we're taking that previous command as the input into the dispatch command, which will provide it as the payload. So I run that, and clearly Nomad did work. And you can see there's an allocation ID right here. So I'm going to want that. But first, let's go ahead and do Nomad status hi again. So now you can see that there's one running, which would be our instance. So I want to look at the logs for it. All right. 826. There. Hello, HashiTalks. As advertised, that works. I can also exec into this. So now I have a bash context within here. I can do an ls. I can also look at the inf. So in here, you can see all sorts of stuff, including Nomad taskdir, which I showed you before. So the reason we needed that before is that our file actually ends up inside this local dir. So I can go in there, and we see message.txt. If I cat it, it says HashiTalks. So nothing surprising here. We like to build our stuff based around first principles. Everything sort of feels natural. It feels like you're writing a script in any context, not necessarily within an isolated container running inside of a distributed system. So let's go back to the talk here. And if you're seeing this for the first time, then hopefully you'll learn something. But I bet no matter what, this is sort of your reaction. It's not exactly impressive. That's fine. Like I said, it's the simplest imaginable instance of a parameterized job. So let's focus on something a little more real this time. Let's just say, for instance, that I have various data sets about the entire world. And I want to make a chloroplet, which is a map where you're coloring the regions proportionally according to some value. You've seen them popular with political maps and all sorts of stuff like that. I don't exactly know what map projection I want yet, but I know that seeing is believing, so I'm going to want to dabble. So I want to quickly generate a variety of options of this map. How can I do this with a parameterized job? Let's consider the tools we have available. We know we have metaparams, which are those to pass in quick little strings or identifiers, and then a payload for sort of a larger blob of information. So this sounds like it maps to what we need. The metaparams could be good for specifying a projection, since that's just going to be like a little string. The payload will be better for attaching the entire data set, right? Big old blob of data, makes sense. Unfortunately, there's a catch. The maximum payload size for a dispatch job is only 16 kilobytes. And I don't know if you know this, but the world's pretty big, bigger than that. So I don't think this is going to cut it. Before I go into the workaround, I want to explain why this is the limit. So just go back to the workflow, the flow chart I showed earlier. And imagine what's happening when you dispatch a job. You have to take that entire request from the computer that ran the command, and you have to ship it to the server. And the server has to process it, and then it has to transfer it to the client, and then the client gets to run it. Do you really want to take all of that data and then make it do all these hops? Additionally, servers, there are going to be multiple of them, and they have to share state in case one of them goes down and another one gets to assume the role of leader. So you don't really want to have all of that state shared as well. So there's got to be a better way, right? And there is. As it turns out, shuffling data around is kind of a primary responsibility of a distributed system. And in Nomad, there is this general purpose utility called an artifact. So with the artifact stanza, what we could do is we could specify a source, which is just going to be a URL, and then a destination. So wherever inside your task you want this to go. And then what'll happen is Nomad will place the allocation on the client. And then within the allocation, it's going to pull this data before starting the task. So this is exactly what we want, because this means we're not plumbing it all the way through the server from our computer. You can also see it here, it says mode file. The default mode is going to be a directory. Artifact will also automatically unzip archives for you if that's what you're dealing with, but we're just dealing with one file. That's great, but it's just static configuration, right? So we have to combine some concepts to make this actually work for us. So let's reimagine that payload of data as instead a meta property of just the data file. So now it's a URL. So now what we can do is inside the artifact stanza, inside of source, we can interpolate the metadata file as the value. So then it will pull this dynamic file that we configure when we dispatch, similar to what we saw when we were catting that message.txt file. Okay, that's a lot all at once. So let's kind of zoom out and look at how this changes. So now inside of that job dispatch in the bottom left, we have a couple meta params. We have a data file, and then we have a projection. That data file gets provided to the artifact stanza, which means that we're going to pull down this JSON file from the cloud somewhere. So once we do that, the result is an allocation placed on some client. And then inside of that allocation, we will have in the end those two meta properties, as well as this file that gets downloaded before the task starts. All right, I said this was hypothetical. It's not. I actually made this thing. So let's do a demo. I'm going to have to bring up some windows that are well placed. Cool. Okay. Clearly, it's been more than 2 minutes because our previous high job now has one dead child job. So that sleep 120 expired, and then it went into a complete state. So the job is officially deemed dead. Over here in our terminal, let's go ahead and start our new job. So this job is called Make Maps. And now it exists. We can see it in the UI, Make Map, no children. We haven't launched anything yet. Let's go in there. And then we can launch one. Let me show you the command and kind of walk you through what's going to happen before I do anything here. So Nomad job dispatch, just like before. This time we're using meta properties. So we have to provide meta, the name of the meta property here, and then the URL. So that's our data file. And then meta projection, and we're going to use Gingery. And then make map, which is the name of the job. So I'll run that. It instantly goes into this running state, but you can see the allocation still in this starting state. Eventually it'll go to running. And then when it's complete, if everything goes well, we'll see an SVG show up in here. All right, so job works. We have a projection. Here is a pretty beautiful map. It is colored based off of population data from 2005, because that's the file I found on the internet. Not exactly up to date. This projection, although pretty cool looking, is a little US centric for my taste. So I want to play with some more options. I know there are other map projections out there, so let's see. In fact, I want to see a lot of them all at once. I have this script here that's going to fire off 25 dispatch jobs at once. So yeah, let's just do it and see what happens, right? So immediately 1 starts, 2 starts, 3 starts, but then something interesting happens. Work starts getting into this pending state instead of running. And that's because Nomad will accept work, and if it can't place it, it'll hold on to it in this sort of queue state until there's space made available, either because you added more nodes or because work finished. So this means that an emergent property of existing functionality in the scheduler means we can use parameterized jobs as sort of a queuing system. Maybe not the highest throughput queuing system in the world, but very often good enough. So we can see that as I've been talking, jobs have been finishing, and we've got more maps coming out. Let's look at a couple more of these. Equal area, this is pretty nice. I like this. This one's armadillo. No Antarctica, which I guess is fine for a lot of circumstances. I got this one. It's kind of funny looking at the poles. And this one's just kind of plain funny looking. As this is running a little bit longer, I can drop some map trivia on you. First off, the reason why there are so many projections is that the Earth is, not flat. Hopefully you know that. But what that means is that when you represent it in 2 dimensions, it's always going to be compromised. You have to stretch it somewhere. It's going to be distorted, unless it's actually a 3-dimensional globe. So then it's a matter of how do you want to distort it? Do you want to distort it to favor a certain region? Do you want to distort it to favor a certain aspect? So the 2 most common things you're looking for when you're creating a map is you either want equal area, like you can see here. An equal area is good for chloroplasts because it means that everything is true to size proportionally. So this is actually how Africa looks proportional to South America and Europe. Or you want things to be equal distance, like this one. So if you're wayfinding and you want to measure distances, then you actually do want to know how far Madagascar is from Australia, even though Australia isn't actually this chunkus. All right, a couple more of these are showing up. This one's one of my favorites, butterfly watermelon. I can talk about maps all day, but instead I won't. And I'll just let this sort of run in the background and go back to slides. So, keynote. Hopefully you like just looking at maps, but I also have one more thing I wanted to talk about this demo, which is kind of neat. I don't know, we'll see. It's that it didn't use Docker at all. You might find this shocking. I tried my hardest to make this slide look like a YouTube clickbait thumbnail with a horrible drop shadow and whatnot. But yeah, no Docker. So Docker and orchestrators go hand in hand. Everyone's talking about how you have to containerize things where you can be cloud native, et cetera, et cetera. And that's cool. I've got nothing against Docker. Docker's great. I use it. I mean, sometimes it feels like Docker has something against me and it takes forever to debug stuff. But like, I mean, that's just software, right? But I just think at a philosophical level, maybe we shouldn't always have to use Docker. Maybe we shouldn't just accept Docker as a given. And philosophically, I'm in line with HashiCorp and Nomad here. In fact, the title of HashiCorp is workflows, not technologies. And what this means in terms of Nomad is we should support heterogeneous workloads. We shouldn't assume that everything is in Docker. We should try to be where users are, or at least where they want to be. So I've been using this exec task driver instead. And you can see the artifact stanza showing up again. So instead of pulling a container from some registry, it's just downloading it from the internet. And then inside of the command, it just runs the binary. So this SVG script is actually a Node script that I converted into a binary using a tool called package, which you can find if you just Google Node and then PKG. And then the driver exec is actually kind of neat. So you still get an isolated context within a C group, but you don't have to use, you don't need like an entire emulated Ubuntu or what have you inside of it. The keen observer may have noticed that what this basically means is I'm downloading something off the internet and then immediately executing it. And that is not exactly a best practice. I will assure you that this is just a YOLO demo code and that there are conventions or options rather to do things like checksumming or providing authentication for private file servers and whatnot. Cool. So let's recap then. What did we go over? First, we went over what Nomad is, and it's HashiCorp's workload orchestrator. We looked at parameterized jobs, which is a way of modeling batch jobs as a template. We then looked at Nomad job dispatch, which is a way of launching a specific job based on that parameterized template. And then we can provide a payload or meta params, which are just two different ways of giving context to whatever is running inside of that dispatch job. And then we looked at artifacts, which is just another Nomad concept for downloading files that ends up playing really nicely with our dispatch jobs. And then we looked at this exec driver because maybe you don't need to containerize everything. Nothing against containers, but you know, binaries exist also, and they're pretty cool. And then my favorite part, we looked at map projections. Hopefully you are also a fan of them. So that's kind of that. If you are already a Nomad user, hopefully you're able to gain something from this talk. Hopefully it made you think about what you currently do and maybe some ways that you can tweak some stuff. If you're not a Nomad user already, I hope that this was indeed beginner friendly. And if you're looking for additional resources, we have two great ones. You can go to learn.hashicorp.com/nomad. And from there, you can go through a variety of guides about Nomad to get started, to run jobs, about clustering, about security. And then we also have our community forums for any questions that couldn't be answered with our guides. You can ask, you can get a response from a Nomad engineer or one of our incredibly helpful community members. So that's that. Thank you so much for paying attention to my talk. All the source code for everything I showed, including the Nomad job files, the server configuration, and all the JavaScript for creating those maps is available on my GitHub. Don't go ahead, don't be stressed about writing this down. I'm going to export all the slides and they will also be available online. But thank you so much for having me.
Michael, quick question from the live stream, actually. How do you get the allocation ID directly?
Yeah, so I guess this depends on where you want it. Maybe I can share screen again and I can show you some stuff. So in the first example, nope, that's not the one. That's the behind the scenes terminal. You're not supposed to see that one. In this one, let's scroll through the backlog. When something gets run, you can see that it has this allocation line. So it tells you exactly what the allocation is right there. So that's super convenient for grabbing it. If it's something else, there's a couple commands you can do. So here you can see I have a bunch of jobs at this point. They're all dead, but we'll see. So if I grab any of these and I do Nomad Alex status on it, that's not what I wanted. I wanted job status. Then inside of that will be the allocations table. And then you can see the allocation ID right there also. And then if you aren't CLI inclined, you can get these things out of the UI as well. So here you can see all these job launches, which amounts to what you saw with job status. I can click inside of one of these. And then you can see allocations, there's an ID, and then you can also go in here also.
All right, another question. Is job level wait paradigm coming anytime soon, if at all? I need to mimic Jenkins like workflows so that certain steps don't start until the others are done.
Yes. So I want to divide two different concepts here. So one of them is kind of like within an allocation, can I determine kind of like a startup order of the tasks? And that is coming soon. That we're calling task dependencies. There's actually a PR open, you can see on GitHub. That'll let you basically say task 1 start immediately, task 2 don't start until that pre-start task finished. There's another concept which is kind of to take at the job level and create directed acyclic graphs to set up all sorts of like priority type things. And that is not slated, but we are looking into expanding our ecosystem team to bring first class support to tools like Airflow for that.